8.1 Conversions and Dosage Measurement. This section will help you practice common conversions used in the health fields, become familiar with the equipment used to measure medicine. Let's start with common conversions used in the health fields. Measurement and measurement conversions are very important to health professionals. Medication is usually prescribed as a unit of weight, and the correct unit of volume or capacity must be identified to deliver the correct dose. Health professionals must be proficient at converting measurements in the metric system, US system, and converting between these two systems. Okay, so we have a table here, and this is common conversions in the US system. So these equivalencies should be familiar to you. And down here, we have the metric prefixes commonly used by health professionals. Now, we've learned about the metric system already, but these are the prefixes that are most used in the health professions. So we have kilo, and then going from kilo, we skip a bunch of prefixes and we go now straight to the actual unit. So whether it's meters, liters, or grams, so we're going to convert from kilo to the actual unit, we move the decimal 3 places. Now the next unit is going from the actual unit to milli, and again, that is 3 decimal places. Very convenient. And then the last one is when we're going from milli to micro, and micro may be a new one to us, but it's no different than the other metric prefixes, and it's very convenient that again we're moving 3 decimal places. So it's really nice that in the health fields they use these 1, 2, 3, 4 different metric prefixes, and they all happen to be 3 decimal places apart. Here are the conversions we're going to want to be familiar with between the metric and the US system of measure. So we have inches to centimeters, kilograms to pounds, fluid ounces to milliliters, teaspoons to milliliters, and then liter to quarts, and this is not actually precise here. Let's cross that out. This is actually just approximately equal to a quart. Very close, but approximately equal to. And then 1 quart is 32 fluid ounces. Finally, 1 cc is equal to 1 milliliter. So 1 cubic center and 1 milliliter are the same thing. Let's take a look at example 1 now. A child is taking 5 milliliters of cough medicine 3 times a day. If the full bottle contains 3 fluid ounces, how many days will the cough medicine last? Well, a lot of information going on here. Let's start right here. The child is taking 5 milliliters of cough medicine 3 times a day. Let's figure out how much cough medicine they're taking in a full day. So we're going to look at 1 day here. So let's see, 5 milliliters 3 times a day. So basically we have this, 5 milliliters, but we're going to take that 3 times a day, so we're going to multiply that by 3. So that's going to give us 15 milliliters a day. Okay? Now let's take a look. A full bottle contains 3 fluid ounces. 3 fluid ounces. Well, let's figure out how much that's going to be in milliliters. So I'd start as I always do when I'm making conversions. I'd say 3 fluid ounces. I'd write that as a fraction by putting it over 1. Now what I want to do is I want to multiply over here by a conversion fraction. And so we're going to need this right here. We're going to need 1 fluid ounce is 30 milliliters. So I want to put the fluid ounce down here. 1 fluid ounce and the 30 milliliters up here. The reason I'm doing that is I want this old unit of volume to divide out for me. So the fluid ounces are dividing out, and I'm going to be left with milliliters. So it looks like all I have to do here is take 3 times 30. So that's going to give me 90 milliliters. All right, 90 milliliters. That's how much cough syrup I have. I'm using 15 milliliters a day. So if I take 90 and divide it by 15 mLs, let's see, 90 divided by 15 is going to give me 6. So this cough medicine is going to last 6 days, given at that rate. Now it's time to check your understanding of converting between the US system and the metric system. Pause your video player now and answer these practice questions. When you're done, hit play to see how you did. Practice 2. A child has a head circumference of 52 centimeters. An interested parent wants to know how many inches that is. What do you tell the parent? Well, we need to take 52 centimeters over 1, we write it as a fraction, and now we want to convert. So we want to divide out the old units of centimeters and introduce now inches. So from your chart, you're going to see that 2.54 centimeters is equal to 1 inch. So our centimeters divide out nicely. And so now what we're going to do is we're going to take 52 and divide it by 2.54. Okay, and that's going to give us then 20.47 inches. Since we're telling this information to the parent, we would probably just say, okay, interested parent, that's 20.5 inches in circumference. Question 3. Convert 250 micrograms to milligrams. So here we have 250 micrograms, and we want to convert that now into milligrams. Well, to go from micrograms, the smaller unit, to milligrams, we're going to move the decimal 3 places to the left. So that in the number 250, the decimal starts right there. We want to move this 3 places to the left. 1, 2, 3. So that is going to be 0.25. We could write the 0 on the end, but it's not necessary. So 0.25 milligrams. Now we want to make doggone sure that we write this 0 out front of the decimal point. In all health professions, we always write the 0 in front of the decimal point to make sure nobody misses that decimal point when we're looking at things. Okay? Question 4. Convert 20 fluid ounces into liters. All right, we'll start with this. 20 fluid ounces over 1. And now we want to convert this into liters. Well, let's see. We know this, that there are 32 fluid ounces in 1 quart. And at the same time, approximately 1 quart is equal to 1 liter. Okay, so let's check our units here and make sure we have this thing set up right. So fluid ounces is dividing out. Quarts and quarts are dividing out. That's going to leave us with liters, so we have this thing all set up now. So in terms of math, it looks like all I have to do is take 20 divided by 32 to answer this question. And so this is going to be then 0.625 liters. Sorry, capital L for liters. Practice question 5. A mother is supplementing her breast milk with formula. If the infant gets 4 fluid ounces every 6 hours, how many quarts of formula would you recommend she buy for a 5-day supply? Okay, again, a lot of information going on here. 4 fluid ounces every 6 hours. Let's figure out what's going to go on in 1 day here. So let's see, 4 fluid ounces every 6 hours. So that means if we're going to give this medication every 6 hours, that means we're giving it 4 times a day. And I figured that out by saying, okay, there's 24 hours in the day. We're going to give it every 6 hours, which means we're giving this thing 4 times a day. Okay, so it looks like we're giving 4 fluid ounces 4 times a day. So I'm going to take 4 times 4 fluid ounces, and that's going to give me 16 fluid ounces in 1 day. So that's what's happening in 1 day there. 16 fluid ounces. All right, how many quarts of formula would you recommend she buy for a 5-day supply? Well, if we're using 16 a day, all we got to do is take 5 times the 16, and then that's going to give us 80 fluid ounces for a 5-day supply. Next thing we're going to take a look at is converting between Celsius and Fahrenheit. And so we have 2 formulas here. What this one does, this first one here, given a Celsius degree, a temperature, we're going to plug a Celsius temperature in there for C, and then we would get a Fahrenheit equivalent out of that. The other way around, if we are starting with a Fahrenheit and we want to convert that to Celsius, we would start with this formula on the right. Now let's take a look at some examples that will help you convert between Celsius and Fahrenheit. Example 1. We're asked to convert 45 degrees Celsius into Fahrenheit. So we're starting with Celsius, going into Fahrenheit, so we want to use this formula. There's my formula. I know that I have 45 degrees Celsius, so I want to plug that in there. So let's see, I'd have F equals 9/5. I'm putting 40 and 45 in here, but let me write that as a fraction since I'm going to multiply it by 9/5. So that's 45 over 1 plus 32. Well, before I multiply right here, notice there's a common factor of 5 and 45 and 5, so I'm going to divide that out first. So 5 divided by 5 is 1, and then 45 divided by 5 will give me 9. All right, working our way up here, let's see. So then I'm going to have 9 times 9, or 81, when I get done with that multiplication, plus 32. And so 81 plus 32 is going to give me 113. So 113 degrees Fahrenheit. Next example, we're converting now 50 degrees Fahrenheit into Celsius. So I want to start with this formula then. Okay, now I'm plugging 50 degrees Fahrenheit in there for F. So see, it would look like this. 5 times 50. Okay, so 5 times 50, that's going to give me 250. So I'll have 250 minus 160 over 9. Let's go ahead and do that now. So I'm going to take 250 minus 160. That gives me 90 divided by 9 is going to give me 10. So that's going to be 10 degrees Celsius. Now it's time to pause your video player and practice converting between Celsius and Fahrenheit. When you get done with these two practice questions, hit play to see how you did. So I used the formula that's going to convert Celsius to Fahrenheit. I've already plugged the 15 degrees in for Celsius. Now I'm going to get ready to multiply. Let's write that 15 as a fraction. Again, a nice common factor of 5 will divide out for us. That'd leave a 1. That would leave a 3. So really all I'm left to do there is multiply that 9 times the 3, which is going to give me 27. And 27 plus 32. So that's going to give me a temperature then of 59 degrees Fahrenheit. Question 3, I've taken 41 degrees Fahrenheit, plug that in to my equation here. That's going to convert for me. Now all I have to do is calculate what's going on here. So let's see, 5 times 41, it's going to give me 205. And so then if I take 205 minus 160, I get 45 divided by 9 is going to give me 5 degrees Celsius. The equipment used to administer medicine. Accurate measurement is an important part of administering the correct amount of medicine. So here are some devices that we use to dispense oral medication. So we have a dropper here, and that has a scale on the side. We have a medicine spoon here, and basically what you do is you flip this medicine spoon up, and then you'd fill it up to whatever amount of medication you need, and then you can tip it and then administer the medicine orally that way. The other thing we have is a syringe, but this is an oral syringe, so that we could measure exactly and precisely how much medication we needed on the oral syringe and administer it that way. Or we also have a dosage cup, which has all kinds of measurement on the side, and we can fill up the cup to the right amount of the right dosage of medication and then administer it that way. The next thing we're looking at here are injection and intravenous syringes. So basically we could take one of these syringes and either use it for an injection, or we could use it and we could administer this medication through an IV. And so we have a 35 milliliter syringe, 12 milliliter syringe, 5 milliliter syringe, 3 milliliter syringe, and a 1 milliliter syringe, depending on how potent the medication is and how large the patient is that we're administering the medicine. Example 6. Draw a line from the listed volume and match it to the correct syringe. Once we get it matched, go ahead and shade the indicated volume of medicine on the syringe. So let's take a look. We got three different volumes here. 31 milliliters. Well, that's only going to work on this 35 milliliter syringe. You know, it says 35 cc's on the end, but remember a cc is the same thing as a milliliter. So I want to shade 31 milliliters on that. So basically I'd shade this thing right up to there. Okay, 3.6 milliliters. That one we're going to want to match with this small syringe up here. So let's see, shading in 3.6 on there. Now let's stop at 3 here and look a little closely. Notice there's only 5 tick marks between these two. That means those tick marks are going by 2. So if I filled to 3, this would be 3.2 to that level, 3.4 to that level, and then 3.6 is right there. 9.2 milliliters. We're going to put that one on the middle syringe. So let's shade up to 9 and then we'll think about it here. So shading up to 9. Okay, again, we're only looking at 5 tick marks in here, so each one of them is 2. So I'm going to want to shade just to that mark right there. Now it's time to practice this idea. Pause your video player and match these volumes up with the correct syringe. Once you get them matched, go ahead and shade the syringe. When you're done, hit play to see how you did. Okay, so 4 milliliters. That is the only one big enough to do that is going to be this one down at the bottom. So we're shading in 4 milliliters here. So we want to shade it in right to there. That's how we'd fill that one up. 2.5 milliliters. Well, that's going to go on this 3 milliliter syringe right here. So let's see. There's 1, 1.5, 2. Now notice these are 10 tick marks in there, and it actually got this thing marked right there, 2.5 milliliters. So we're going to shade it right up to that amount right there. Okay, 0.5 milliliters. So that's half a milliliter. This is a 1 milliliter syringe. So we're going to shade this one up halfway. So 0.2, 0.3, 0.4, right there, 0.5. So in that last syringe shading we just did, you may have noticed that we could have put the 0.5 milliliters using either the 1 milliliter syringe or 3 milliliter syringe. To make sure that measurements are as accurate as possible, always choose the smallest syringe that will do the job. Let's say that a mistake was made and each syringe was filled to 1 tick mark over the 0.5 milliliters we were supposed to administer. Now on the smaller syringe, if we went 1 tick mark over, we would then be administering 0.51 milliliters. Let's look at what this results in as an overdose. We're going to give the patient an overdose here if we put in 0.51 milliliters. Let's see how much of an overdose we're giving them. So to calculate this overdose, remember we're going to use a percent increase. So that's the change over the original. So the change that happened here is the overdose that we gave. We gave them 0.01 milliliters too much up top. The original is a 0.5 milliliter dose. So that gives us a 2% overdose with that smaller syringe. Now let's take a look at the overdose with a larger syringe. Well, if we go 1 tick mark too much on the larger syringe, then we're given a 0.6 milliliter overdose. Go through, calculate the percent change. Our overdose now is 0.1 milliliters. And again, the same original, 0.5. That results in a 20% overdose. That's a very significant overdose. So a mistake on the 3 milliliter syringe gives a 20% overdose, which is 10 times the amount of a 2% overdose with the smaller 1 milliliter syringe. So the smaller syringe is 10 times more accurate at measuring this dose. So always use the smallest syringe that will do the job to make sure you're being accurate. Now pause your video player and shade 1.3 milliliters of this is an intermuscular injection syringe that is the best size. When you're done, hit play to see how you did. Okay, so we want to shade 1.3 milliliters. The 1 milliliter syringe is not going to be big enough. We can't use that. So really we have a choice of either the 3 milliliter syringe or the 5 milliliter syringe. Well, always choose the smallest one that's going to do the job. So we're not going to use the 5 cc syringe here either. So let's see, 1.3 milliliters. So first we shade this in. Let's get up to 1. And let's see. There are 10 marks between our units here. That means everything is going by 0.1 then. So this would be 1.1, 1.2, 1.3 milliliters. And we want to shade that on the 3 milliliter syringe. If you haven't already done this question, pause your video player and do it. And then hit play to see how you did. All right, question 9. Shade 4.5 milliliters on the intermuscular syringe. That is the best size. Well, 1 milliliter too small. 3 milliliters too small. We're going to shade this in on the bottom one. Let's see, we need 4.5. So let's get up to 4 and then we'll start thinking. Okay, 4.5. There's 5 tick marks here. That means each of these is going by 2. So here's 4.2, 4.4 to that point. So we want to go right down the middle, halfway there, to get 4.5 milliliters.